Okay, so welcome aboard again, everybody. So we are going to record our session and it will be posted to the ARPDC site. And I'm aware that the last one isn't there, and we're going to work on that one here right away to get that one up to see why it's held up. But nonetheless, when you are looking for the ARPDC site is where you're going to go, same place that you found session 1. And you'll have session 2. This is now your session 3 that will be both posted in there as well. So we've got lots that we kind of want to cover today. And I really want to emphasize some of the things in particular that we know have been materials that the students may not have come to our doorstep with and been really proficient with. So in this case, we want to also talk a little bit about what do I need to back up to, what do I need to back up to, but also hearing a lot from teachers right now saying they're weak. And so my question is always, are they weak in math, or are they weak because they didn't have the background knowledge? And right now we have to be really careful where we put them into which silo we're kind of saying they belong to, because if they don't know something about a concept that we're just going to just launch right into grade 6 concepts and think that they know the background knowledge, then that's on us to make sure that we go back and make sure we find out what it is that outcome is assuming they already know. And if they don't, then we have to do some of that bridging. And that's going to be our world for a little while. This year, for sure. There's no question about that. And maybe to a certain degree, it's going to be next year as well. We're not going to have any differences there. So we're going to talk a little bit about that as well as we go through today. So a lot of times I might flip back to, if we're following our year at a glance, we did touch on September or December already, but I'm going to go back and pick up things that people have been asking me about that I know kind of are holding you up. So it may or may not be a fit for you. Bear with us if it isn't. But just sort of be aware that this is some things that kids are stumbling on, or maybe you did them in a different order and you haven't gotten to that yet. So then you can keep that in the back of your mind as you're going through. So let's begin with our acknowledgement. We respectfully acknowledge that we are situated on traditional lands across the province of Alberta, home to many First Nations, including the Cree, Blackfoot, Métis, Nakota Sioux, Saulteaux, and Inuit, and many others whose languages and histories and cultures continue to influence our vibrant community. So as I said, I am going to take a little bit of a step back, and I want to review this one. Although we kind of said as a goal, we would kind of have that one done sort of the beginning of December, if not sort of the end of December, but we're finding that that's a bit of a stumbling block. And I think I'm kind of knowing why. Maybe kids don't know what it is. They can't visualize what it is you're wanting them to learn. So we're going to go back and do a little bit of work there. We're going to go back and do a little bit of work at 6 and 4 as well. And then we're going to start on 6, we'll do 6 and 5, but we're also going to work on fractions, but we're going to not do the whole thing, because when we come back again, we meet again in February, I'm going to start with that again. So we're going to make some initial steps into it, but we're not going to get deep into it because I'm pretty sure that we won't all be there at that point. So again, all of you might be at different places because you aren't required to follow this year at a glance. But if you are, that's kind of how we're unpacking it as well. Okay, so one of the things I do want to just highlight for you right now is some of those skills and procedures, those verbs that have been showing up. These are kind of a compilation of some of the ones that are in these next 3 months, but they're certainly not unique to these 3 months. They've been carried over because remember, we are revisiting these outcomes continuously, just tooling up their end goal in each one of them. And so I just want to bring them to your attention. I'm not going to go through them individually, but I do want you to recognize that there are some that continuously show up, such as representation, modeling, describe, explain, investigate, explore. Some of those ones are going to come up in every organizing idea. It doesn't really matter what we're teaching them. And so when some of you are saying, I don't have time to assess everything super deeply in those verbs, then maybe it's the big rocks of the ones that we're seeing consistently show up right now that you really hang your hat on right now. You're still teaching them all. You're not going to say, well, I don't have time, so I'm not doing them. You're still cognizant of how that drives your instruction. But maybe you're not deep diving into assessments with every verb that you have there, especially if you're combining some of them, you wouldn't need to anyway. But my point would be, in this case, what we really want them to do is have a good understanding. And those ones that I just said to you are the same ones that we see in science. Whether I talk science in kindergarten or science in grade 6, they are identical in science as big rocks that we have already highlighted as they showed up in kindergarten and they worked their way through to grade 6. And remember that these verbs, although we have them right up here on the screen in a math session, they're not specific to math. They are, any subject would have an investigation or an exploration or a representation. And so we don't want students just to think that you're teaching me those terminologies and those applications, and they are exclusive to science or math. They're not. They would show up in language arts, they would show up in social studies, they'll show up in health. And students need to hear that and see that it is fluid. This is not about the verbs that we see in math. And this is what I have to demonstrate in math only. So I bring that to your attention. In your slide deck today, you're going to have slide decks built into the slide deck. So every time you see a hyperlink, it's probably either just a slide deck or a template that you have. In this case, I know this is hard to read. So this is on a spreadsheet down here, so you can just go through it. But I won't go through that now. I just wanted to bring it up because we haven't done that for a while, and I just wanted to make sure that we were clear on that. I'm going to go back to my hat and put it on and say that money is one of our strongest manipulatives that we have right now. And for a lot of our students, it's filling in the holes of those areas that they're really struggling with. It is one of those pieces that we could really leverage to have better understanding. That is not to say that we're throwing away any of our other manipulatives, just making it real. And that's kind of been my soapbox for the last 2 months in sessions as I go out to schools is, could we make the math as real and visual as possible? The more visual it is, the more likely they are to make those connections. And I'm not suggesting that we're going to do manipulative forever in front of them, but just a week of them isn't enough. I need them to be really solid in the understanding. And I said this morning in one of my examples to the teachers, I said, one of the best compliments that I ever got from a student was when we were teaching them about manipulatives. And he was a grade 12 student. He said, I don't want to do any more of these. And I said, what's your problem? He said, I went home last night. He said, it was like a nightmare. I closed my eyes. I could only see those manipulatives. He said, I almost dreamt about them. He said, that's a nightmare. I said, well, that's a good nightmare. I'm so happy to hear that. But that's really almost where I want the kids to be, so that they understand how we're going to get to this symbolic and paper and pencil stuff. So just because they're in grade 6 doesn't mean that they know it all, and it doesn't mean that they should know it all. So we need to slow down, and we need to make sure that they have a good understanding. So if you're finding they're weak or they have some holes, maybe the more you can put those manipulatives in front of them, the better that would be. Okay, so I just want to, I'm not going to go through and reteach what we've already done, but we already talked about sort of the September, October, November. And so just to just point out again that we've been working on 6N 1.1, these ones are going to keep coming up over and over and over again. So we looked at magnitude, we looked at introduction of positive and negative numbers, the integers. We looked at how we would do some problem solving with that. We looked at how they integrate into the real world. How what I would reflect a -1 could be a basement level of a parkade, those types of things, right? So we've covered some of those pieces, and just because we covered them doesn't mean we won't bring them back in somewhere else. And everywhere you can, loop back and grab it. It doesn't have to be part of your lesson plan. Make it a teachable moment and just grab it and ask them a question if it fits in. But equally as well is this one over here, 3N1 and 3.1 and 3.2. Some people are saying I'm just actually starting that, but there were quite a few that I've gotten questions about, could we go back and do that again? Because the first time we did it, I didn't really catch on and I wasn't there, and now I am, and I'm finding that the kids aren't getting it. So I do want to go back and maybe just have a little bit of a different approach to how can we teach students, first of all, a prime number and a composite number. Like, do they even know what those are? And if they do, that's great. Do they know what it means? Not just regurgitate the formula or the definition to us, but do they actually know what that means? And that's the piece that we've been kind of unraveling as a hands-on approach today. Now, because we're not in person, we're going to just do it virtually. I will do it with you, and you can actually join in if you'd like. But But the point is, I want them to be able to see what these look like. And because we're also in grade 6 moving to what are the prime factors, we want to take those prime factors and express them with an exponent. I really have to know what a prime number is to begin with, so I have a good sense of what that means. And then they integrate that both into factors, that terminalization of factorizing something or finding the factors of a number. So I'm going to revisit this very briefly. I'm not going to spend a ton of time on it. We also integrated our geometry and coordinate geometry into the same teachable moments, because if I'm going to teach you about different shapes and symmetry and all of those components, then I might also include that as I'm putting them into the Cartesian plane. I'm looking at what the coordinates of the vertices are, so I don't have to make these discrete units. And that was a comment that we made early in the year. We said, this is maybe not the year to think that I'm doing place value for the next 3 weeks. This is when I've always done it. Maybe it's about the outcome and what can I connect together in outcomes versus the unit, because I have to keep revisiting. And as I revisit, they get stronger, and the goal is changing a little bit every time. The idea was that if we're going to scaffold, that's why we put the yellows in, and just as in, especially if we had numbers that were, and I'll just draw one at random. Let's say that the goal that I had to get to with the students was 1 million, where in fact they were just at 1,000 before. To go to 1 million and say that's my outcome and that's what I'm going to be working on for the next 2 weeks, I'm just going to tell them and I'm going to get them there, then this is at best memorization, maybe, or maybe not even that for some of them. So why don't we not do that? So we said, why don't we scaffold? We can go back and start maybe at 100, then go to 1,000, then go to 5,000. Small increments, same outcome, revisit, tool it up with something else that it fits to. Maybe it's an addition question that I can be doing at the same time, subtraction questions. I don't have to do an entire unit all in one shot. Not saying that you couldn't. I'm just saying this is maybe the year that you might struggle a little bit more with it just because the kids don't have the background knowledge. So again, that prime factorization and prime factors, even the term factors has come up many times, saying the kids don't know what a factor is. They don't know how to interpret that. So again, we can talk a little bit about that. And then having that order of operations that we're talking about, we're basically bringing the junior high piece down and doing the exponents and the whole, basically the whole gambit of the order of operations. So one of the questions that I was asked this morning, I don't have the answer to it because it's not here in our curriculum, but is, how big do we get? If the students aren't going to be able to use their calculators on this test, how big should the bases be? And you and I both know that when you start using exponents, numbers get big quickly. So we're not going to throw numbers with bases of 5s and ask them to do exponents of 6 and 7 and 8. We wouldn't even do that even when we were doing them before in junior high. Keep it reasonable. It's the process and the understanding we're looking for. It is not about how big the base is. So a base of 1, a base of 2, a base of 3, and keep those exponents reasonable so that I can do those in my head or just simply paper and pencil, because that's going to be a factor in some of the things that we do as well. Knowing my math facts has also been something that's come up. The kids don't know their facts. And so now I'm supposed to do long division, and oh my gosh, they're struggling with that because they don't even know their basic facts to be able to do that, or they can't do multiplication properly because they don't know their facts. So again, one of the things that we need to do is look at, first of all, our outcomes. They don't say only the standard algorithm. They say can be facilitated by, could be, should be. It doesn't say only. So yes, the standard algorithm is something we want to have students learn, but truthfully, if that's not working, and how many times do you want to give me a new question and have me do it again and again and again, I'm still not getting it. That process does not work for every child. So then it's incumbent on us to find what does work for you. Show me another way, and I might go, oh, okay, yeah, that makes sense. Or, no, I don't know, that doesn't make any more sense than the first one was. So we need to have some tools in our back pocket that we can provide students with. And the other thing I want to say here is, if I don't know my math facts, then I need to show you a strategy that you might be able to do multiplication, but even more so, it's division. That's usually the big holdup for people. How do I do it? if I don't know my math facts? What are my options? So how do I go to a PAD exam and still have success in a division question when I don't know what 6 times 9 is? I don't have no idea what that is. So again, we'll look at some possibilities that we can incorporate in there as well. Again, nothing's going to be perfect, but we want to have some of those options in there. So first of all, a good understanding of primes and composites. That's going to be really important. There's a couple of things. We're going to do the Cuisenaire rods here, and I'm just going to, do the students know what a composite number is? Do they know what a prime number is? If they don't, well, we're going to start with that, and then we can move forward. I'm not going to do that whole, redo the whole outcome. But my aha moment yesterday was we had a lot of people who'd never even seen Cuisenaire rods. So it was kind of assumed that that was a K to 3 thing, and it doesn't really hit Div 2. So this may be something that's very new to you as well. So I'm not going to go through the whole process of what they are because we don't have time to do that. I'm just going to do it with you in the same way that I would if a student who's never seen them before too. We can do it the same way. But having said that, last year we started at request from teachers, could you do a series of presentations that unpack all of these manipulatives? So I have started some of them. There's 6 more to get posted, but how to use Cuisenaire rods, there's several different sections of them and different elements that you would use them in. We're actually going to include the primes and composites that I'm going to do with you today. That will also be in that list. So you might want to check this out. Remember, when you get the slide deck, all of these are hyperlinked, so you can go in and get them. So if you've never worked with a Cuisenaire rod before, you might want to do it with me, or you can just watch along. But what I want to do is just quickly unpack some of this. So let me just bring this up, and I will put it in the chat box. So if you want to go along with me and do it, that's great. And let me just grab our chat. Okay, so it's in the chat box if you want to grab it. And so Cuisenaire rods are simply rods of different colors. And as I bring them up just by clicking. If you've never worked with the interactive ones before, just click the colors. Then I see that they're actually not even all the same length. Every one of them is a little bit different. And so if you have the chance, or if you want to do it with me, that would be great. Because I'd like you to take an orange one, and I'd like you to fill that orange one with a color that has to be the same color. There can't be anything missing, and there can't be anything hanging over. So it's got to fit exactly from end to end on the orange. So let me model. Modeling, remember, is one of them, and then kids have to be able to know what that word means. I'm going to model one for you. I know that 2 yellow bars will fit on top of an orange. So just take a minute, and if you're working on one screen, then just flip to the Cuisenaire rods. Go ahead and fill that row with whatever other colors. You might just have to drag and try and see what works if you've never done them before. And that's the good thing. That's what we want students to do too. So go ahead and fill up whatever colors you think will fit on top of there. Oops. And I can truthfully tell you that when they have them in front of them on their desk, much faster than doing it virtually. Okay, if you're a little bit faster than I am, then I'd like you to also do the same thing for the dark green. Find me any colors that you think fit on top of the dark green. Same rules, has to be the same color in whatever row you make. Okay, it can't be a different color. So as I'm building it, I end up with a picture that looks like this. Order of color makes no difference. If you have the white in someplace else, it doesn't make any difference. If you have red somewhere else, it doesn't matter either. But what I've done now is I've created things that are the same on top of an orange rod. If I don't know anything about base 10 block or Cuisenaire rods, no problem. Doesn't matter, because I wouldn't tell the kids anyway what all this stuff is. But there are a couple of things that we can learn right away from what we've done. If you're new to it, we can say to the students, how big is an orange one? What color could I use up here that will tell me how long an orange is? And they will simply say, you've got 10 white little squares up here. So this is 10, whatever that is long, 10 of those units long. Great. And that's very true. This is exactly 10. It's 10 centimeters long. They are 1 centimeter cubes. But that also tells me a couple other things. It tells me how big the red is. The red is 2 of those blocks, so a red is 2. I can go back and look at the gray or the yellow and find out that it's 5 long. So I've learned right off the bat, without putting anything on these rods, and I'm going to say that, I say that purposefully because some teachers say, well, wouldn't it just be better if you just wrote the numbers on there? The answer is no, because a lot of times we want them to think in terms of the concept of what they're building, not the number. Then they just focus on the number. But in this case, I want them to learn what it represents. This is a 10. So that makes this a 5, that makes this a 2, that makes this a 1. So now I can go up here and I could say the same thing. Up here, I see that I have 6 white, so a dark green is 6 white, or 6 long. A light green is 3 long. We already know the red and we already know the white. So I've learned a few things about these 2 bars. Now, bear with me for just 1 second. I want you to do exactly the same thing with the black and the light green. So build whatever colors will fit on top of those in the same way you did the left-hand side there. Okay, so it's kind of having a right side and a left side. And of course, the students will, and so did the adults that we were working with. They simply dragged a whole bunch of them over to see which ones they could fit. And lo and behold, what they found was that they couldn't get anything to fit except the whites. So you kind of know where I'm going to go with this, I hope. So what I would say to students right now is, what have we done with these? What does this represent? So let's go back to the ones that we started with. You said that this was 10. So this bar represents one group of 10, or 1 times 10. The yellow was 2 yellows. Each of them was 5 units long. So this would be 2 times 5 is 10. They all equal 10 because they start and finish at the same place. These were 2 units long and there were 5 of them. So you've created 5 times 2 is 10. These were 1 unit long, so there are 10 of them. 10 times 1 is 10. I have now shown you what math facts of 10 look like. And sometimes our kids who struggle with learning their math facts is because all they see is this bunch of numbers with this time sign in between, but they don't understand what that means. What is it you're asking me to learn? That's what I'm asking you to learn. I'm asking you to learn what constitutes a 10, what could make up a 10 or whatever number we're working on. Here I see the numbers that multiply to 10. So that means that a factor, a number that is one of the numbers that divides into 10, well, 10 is 1. It's an orange one. I see it fit. I see a yellow fits into it. There's 2 of them that fit in. I see red goes in as a factor. There are 5 of them. I see white goes in. There are 10 of those. There's 1s. So not only have I created the math fact, I can also now talk in terms of what are factors that go in. And I could do the same thing up here. I have 1 times 6, 2 times 3, 3 times 2, 6 times 1. But I could even go one step further. And we get to that point and we start to talk about common factors. What is a common factor? We say, well, it's a number that both goes into. Now I could start with the common factor is, what's the common color? What do I see between a 6 and a 10? That's a common color. White will always be. But now I see that red is a common factor. It's a common number that both of them divide by 2. It's a red. So this makes the math more visual. And for some of our kids, that's just the difference between understanding and not having to memorize something that I have no idea where this goes. Now, you might say, well, this is only up to 10. Yeah, that's right. Well, I can put 2 10s together and have them work out 20. I could make the base number 24. Like, you can change it to whatever you want. Okay, I could build them, and that's my base number to start with. And then we figure out all the factors. I do all the same colored rows, and I can do those kinds of things. So I could conceivably put 10 oranges together. You'd have to have them working in teams because you're going to run out of rods pretty quickly. But you get the idea that this now shows them what it is that they're supposed to do. The other thing is that we need to remember to tell students that anytime we multiply something, it's showing us how much surface is being covered by that multiplication. Any multiplication is an area. There's no exceptions to that rule. Anytime you multiply 2 numbers together, whatever those numbers are, you are finding an area. It could be a big area, could be a little area. So now I might say to them, well, we had 2 different sides here that you built. What are the similarities? Remember, compare is one of those strong verbs that we have in here. A Venn diagram, that would be another one. So here we go. What do I see that's similar between this side and this side? So students will say, well, they get rows. There's more than just the block, the one color that you started with. You could build another row. Yeah. What else do you see? Well, the row of white is common to everything. Perfect. What's the differences? Well, the ones on the right only had white. They didn't get any other rows, whereas these guys had multiple rows. So when we say to a student, I want you to learn that a prime number is a number that is divisible by itself and 1, this is what it looks like. So instead of telling me that, let me see it first, and then we can help to define how are these numbers different. When I'm looking at a composite number, if you compose something, you're putting it together. So think of multiple compositions or multiple ways to do that. Well, that's what I did. I have multiple ways that I was able to show you what a green and an orange can come up with. This is what we call a composite number. This is what we call a prime number. So just to start them off there, instead of giving them a definition first and just assuming I've got it, was a wake-up call for me. Because one of my smartest students that I had early on and taught them in grade 6, and I taught them what prime and composite numbers were. I met that child again in grade 8. I was in the class. I said, anybody remember what a prime number is? And he put his hand up. And he said, a prime number is a number that's divisible by 1 in itself. I said, good. What does that mean? I have no idea. I said, really? I said, how's that possible? You just told, he said, that's what you told me. He said, I remember that. I remember that. That's exactly what you taught us. I thought, wow, Chris, did you ever miss the boat? And it's true. I mean, if that's all he got out of it was that I didn't do my job, this is what I needed to show those students. So make it as visible as we can, because that's going to be absolutely important. And that also lets me, as I said, get into things like, what are some common factors? So the bigger the number, the more common factors, the more rows I'm going to see that have common colors on them. So the students can start to tease those out. Yes, I'm going to get to factor trees and I can see what numbers that I can find in common between them if I show them that. But this is the visual starting point. And I think for a lot of our students, they got lost along the way. So again, this is just a thought and a way that we can improve some of that 3.1, 3.2, because that was something that people were bringing up. This reference that I have here for you, this MathLinks 9, is on the website. So you can click it on and you will find access to the book. Go to chapter 3. And here are some pages in that book that will help you with what we're doing here, especially with the exponents. I'm going to talk about exponents in a little bit, but if you're just still working on or haven't yet started and I want a little bit of a more direction, or I want a little bit more of an explanation or more problems that I might want to use, then this will give you a source. I will talk about the CPAR documents in a bit as well, just to show you what other pieces we put in place for you to help out with finding resources. So again, finding prime numbers, prime factorization of a number means, can you break the number down in as many possible ways as possible, or break it down as low as it'll go? And whatever's broken down should be prime numbers by the time we're done. Okay, and just on a side note, if I go back to what I just did in the Cuisenaire rods, I wouldn't just stop there. I would say to the students, grab all the other ones that we haven't used yet, the ones that and make those your base ones. Tell me which ones that were left over that we didn't do. We did the orange and the dark green. We did the black and the light green. What are the other 6? Are they composite numbers or are they prime numbers? And the reason I do that is because often what you'll hear right away is they'll say, oh, the blue one, that's a 9. Oh, that's going to be prime. Anything that's odd is going to be prime. I said, great, prove it. Of course, then they find out that that's not the case. So that not every odd number is going to be prime. Lots of them are, but not every one of them is. So again, it just gives me that opportunity to have them do some exploration. So a factor tree, if you're not familiar with that, a factor tree just says, I want you to find the prime numbers, the prime factorization that multiply to that number. And I could start anywhere. Maybe I don't know my 2 times 12, but I do know 4 times 6. Doesn't matter where you start, as long as you've got the right product to get to 24. I can start anywhere, and I keep branching and breaking these numbers down as low as they can go. In this case, the lowest I'm going to get here, I started with a 2 and a 12. Now my 12 is a 2 and a 6. My 6 became a 2 and a 3. So I have this many 2s times 3 would give me 24, which is correct. And whether I put them in whatever order, it doesn't matter. As long as I use those same 4 numbers and multiply them, I will end up with 24. Your goal is to be able to take numbers that have been repeated. In other words, the base shows up more than once. In this case, the 2 shows up 3 times, is to write it as an exponent, or as a power is the proper term. So 2 to the exponent 3, or the power, gives me 2 cubed times 3. So that means 2 times 2 times 2 times 3, and that will give me 24. Some students don't like factor trees. Most of them do. It's a fun game to do at the board. Just give them a number, and whoever, have them playing teams. Go against whoever's up there, and just, they can start wherever they want. Whoever steps aside and writes down the prime factorization correctly first gets the point, or whatever. But some do it by repeated division, and that's fine. 24 is an even number. I can start with 2. That's an easy place that I can go to. And then as I'm doing my division, I see the number out here. Okay. Or I can do it by common factors. And I can use this to find common factors, by that way as well. So this gives me an opportunity to have students find different ways to come up with these prime numbers. It isn't just, we say 4 times 6 equals 24. What would that look like as a prime factorization? They need some tools, some background knowledge, and how they're going to get there. Whatever works best for you and them is where you kind of want to go. These are all hyperlinked for you as resources that you can use as extensions, as activities. Some of these are just not games, but they definitely are very interactive for the kids, and they have to come up with the right prime factors, and they can check them online as well. So that just gives you an opportunity to have a look at where we're going to go with some of those terminologies. If at any point you have a question, don't hesitate to stop. One of your outcomes too is to show that numbers can be multiplied in any order. The order I multiply them in does not matter. Okay, the order I add them in does not matter. The order I divide in does matter. So in this case, we want to say, does it matter if I go 3 times 2 times 4? Or if I flipped it around to a different order, or if I threw a bracket in here and a bracket over here, will I still get the same answer? I can show them that. Remember to make it visual. Most people do not think of Cuisenaire rods when it comes to order of operations. They think of them as addition, or they think of them in fractions. We can use them there, or what we just did. But they tend not to think about them in these terms. Would I use them for great big ones and long ones? No, it would not be time efficient. But initially, it's just good for them to see that there is a way to visualize some of these. So 3 times 2 times 4, I could say, well, I'm just going to do these 2 together first. So 3 times 2 says 3 groups of 2. So there's 1 here, 1 here, and 1 here. And I have 4 sets of those 3 groups of 2. So 1, 2, 3, 4 sets of 3 groups of 2. Each one of these is equal to a 6. So they could add up the 6s and get 24. They could multiply them, but they can skip count by 2s. I don't really care how they get there. I can find that it actually equals to 24. But then the question is, if I flip the order, put the bracket in a different place, will I still get the same answer? So this one is saying 4 times 3. So 4 groups of 3, and I have 2 sets of those. So here's 1, 2, 3, 4 groups of 3. Here's the second set. I did them vertically. So each one of these was a 3. I can add up each side is 12, 12, and 12 is 24. So yes, it does work. It doesn't matter what order I put them in. Now, if I throw exponents in, of course, that's going to change the possibilities. So this is one way we can do it. But again, I wouldn't use this for exponents. I wouldn't use this for big, long ones because it's going to take them more time than it would be if we were just working on it sort of in an inverted V pattern. This dad's worksheet is an area where you can go and get some worksheets. I'm not a worksheet fanatic or a proponent actually, but if you are looking for some order of operation questions, then go in there and choose some of the ones. And this lets you really differentiate with the students that if you have some students who are not ready for exponents yet, then pick some of the questions from that sheet that would reflect where they're at until there's such time that they're ready to handle that. If you've got some students, the high flyers that are ready to go, and they're ready to do them all, then just select. But don't just hand out the whole sheet. I'm not sure that that's necessarily good use of time either. We want to be strategic about what the students are seeing. You can use that as your formatives. We have also started in the CPAR documents, I'll show you that in just a second, but when we look at, you have resources in your schools right now. We do have resources in the buildings. Just because we weren't handed a book that said, here's your new book for the new curriculum, doesn't mean we are without. What's the time-consuming part of it is to find out where in those books is what I need. So that's one of my roles in working on the CPAR documents, is to find your connections between your existing books and or the books that live in junior high. So if you are a K-6 school or a 4-6 school and you don't have junior high in your building, I strongly suggest you connect with your nearest junior high and ask them for a copy of the 7, 8, 9 book. Just one. You don't have to have them for your kids, just for you, that you have a copy of whatever that resource is that they're using, so that you have some of the materials that you're covering this year that would normally be covered in the grade 7 curriculum. So here you see both of these can come from Math 6, and the page numbers have already been done for you and what might be useful for you in what we just kind of unpacked. These come from Core Knowledge. Core Knowledge is a resource in which they provide a free text resource. It's online. And where I find a connection or a match, I am going to post them so that you have, again, something that you can refer to. I am not suggesting that you just take the student book, photocopy, and give it to everyone, but do have a look at it, because there may be some components, maybe 2 or 3 pages that go side by side that would be really helpful for you in the way you've organized your unit. They're generally, depending on what the topic is that you're going to be, they can be anywhere up to about 24, 30 pages long for the student book. The teacher's guide is generally about 100 pages, if not more. And they are phenomenal. They provide you with the PowerPoint. They provide you with an activity sheet. They provide you with some really good, if you keep going through it and stay to the bottom, you'll find some good assessment questions. And in assessment, I'm not talking about drill and kill. I'm talking about, in some cases, nice open-ended or problem-solving types of questions. And that's really where we want them to get to that deep thinking. So have a look here. There are two resources actually that I found this time that work: factors and multiples, and then one that talks about place value and decimal operations, because that's the other thing that you're working on. So have a look at those when you get this. The CPAR documents, I will take you into that because I do want to just make sure everybody knows how to find them. And I'm a bit of a hold up right now because I have sessions going on this week. So I'm the one who hasn't been putting things forward to get posted right away. But what I'd like you to do is in order to find them, you're always going to go to the ARPDC website. So arpdc.ab.ca. And if I select mathematics, which I'm already in, I'm going to suggest that you always select your grade. It will just save you scrolling through material. If you don't, you're still going to find your stuff. But what happens is what the most recently posted material is will show up first on the website. And it's not necessarily a specific order by grade. So if I want to just limit it to grade 6, then I should put that in there. It'll save me a little bit of searching. However, below that, you will see that there are 4 buttons. Here are your 3 key documents that we unpacked in our opening session, session number 1. So if you ever need to go back and find them, they're here. And here is a button for the CPAR documents as well. Now, what does CPAR stands for? We originally were calling them curriculum support. They've now just been tweaked a little bit so that there's less confusion between what those are. And the CPAR is what teachers have been calling it, so we're just starting to use that term. Are curriculum planning and assessment resources. So kind of trying to find a few places that you can just combine things together and maybe use that as a go-to if you're looking for some resources. They all have this green sheet to them, so you know that when you see that, you found a CPAR document. You just need to read what is it that you're looking for. Now, they're done by organizing idea. So you have, I believe, 7 or 8 numbered outcomes in grade 6. So number, when I click this on, we'll have all 8 of them eventually all stacked in there. If you want to go to patterns, there'll be another one now that'll look for patterns. When you click it on, if there was more than one outcome in patterns, which I don't believe there is, you're going to just have as many documents. So for every learner outcome, there would be a new document. Okay, so in this case, we've only got 6 and 1 posted right now. So here's number 1, but when 2, 3, 4, you'll have the boxes right below that. They'll all be found in the same location. So number 1, and I'm just going to go through this with you just very quickly. You'll have time to go back at your leisure at some point. What you will find in each one of these documents, first of all, is just an opening sort of tablet at the top section. All of the cusps that are in here, you have 3 knowledge, understanding, skills, and procedures in N1 in grade 6. So each one of these is going to have what I'm going to show you now. I'm just going to do one of them. I'm not going to do them all, but each one of them is different. Here are your direct connections to New Learn Alberta's progressions and to the literacy and the competencies as well. If you forget afterwards, when we leave this session, if you forget how to work through this, there's a how do I read this document found in here. This will be updated as well. We have planners that are being developed for you in grades 4, 5, 6 right now. You can see what they look like for K to 3. They're going to be very similar for you in 4 to 6. And as well for assessment, we have them as well. We also have those skills that I showed you at the beginning, those verbs. Those have already been worked on by the ERLC crew, and they have gone through and defined what each of those words mean and provided you a bit of a template of an exemplar. And that's just to help facilitate that we're kind of all using the same language, regardless of where we are and what board we're working at. We just have that same understanding of what those verbs mean. The skills and progressions, those are under development. You're going to see them for K to 3 and for 4 to 6. If you have done anything in science with us, then you have seen what they look like in science already. They will look very similar to that. And this is your numbered outcomes document. At the very top of this document, before I go down, I'm just going to point out to you, there is a date right in the top right-hand corner. These are going to be updated sort of on a monthly basis. So because of the volume of how many of these we are creating and putting out for you, we can't possibly send out an email every time we do an update. So just kind of make a mental note. When was the last time you were in N1? If it was in November that you read it, or this is the last time it was gone into that it's been posted since then. If we go in and do an edit over the Christmas holidays, that date will change. So whoever goes in and does the update, then that date changes, and then you know, oh, there's a December date up there. I didn't know that they must have changed something. So you just need to go through and have a look and see what's been added. So how do they work? You have your organizing idea, your guiding question, and your learner outcome for number 1. N2, this will be a completely different document. Below that, you have an explanation of what transfer is. And remember, we talked about surface, deep, and transfer in session 1. If you need to review that, you should, because it will link to the assessments that have been put in here. Below that, you have a sample summative. Is it perfect? No. Is it a starting point? Sure. You can click any of these on, you can read them through. If you say, oh, I want to use that, fine. There's a blue box at the top, just click it on, it'll download it to your computer in an editable form. If you say, I really like the first 5 questions, but I have some I want to add to it, when you download it, you can take out, add in, put in whatever you want. This is entirely up to you. They're just samples that have been started, and that doesn't mean that there won't be more that are coming. We know that there'll be more coming. Below that, you will have for your first cusp, remember there are 3 rows of knowledge, understanding, skills, and procedures. So we're only going to do the first row. I'll show you what's in there, and then the other 2 will have the same format, just all new information for that cusp. So the first cusp, what you'll find is the prerequisite knowledge that you need to teach that cusp. Any pre-assessment information, if there's pre-assessments you're using from Nelson that link into that, that will go in here. If you have vocabulary, this is just specific to the cusp that you're unpacking. I know I can statements for those of you who are using those. If there are suggestions for enhancements, if you have some, those are going to be added later. But if you have some, this is a combined effort. This is not a 1 or 2 people doing this. So if you have things you want to share with us, just send them. And we will gladly, we might change the format a little bit so it fits with what we've got in here. But we would gladly share your expertise and put it into the documents. And the same thing with learning recovery. So below that, what you're going to see is here is the familiar understanding, knowledge, understanding, skill, and procedures. What you won't see is the entire skills listed for that first cusp. We know that you have to teach that specific skill and assess it. And so what we did is we broke each of them up into their own row. So here we see identify negative numbers in familiar context, blah, blah, blah. Here is an achievement indicator that helps you, and you're familiar with that wording. The illustrative examples are ways to unpack what this means. And that's what we heard from a lot of teachers is, I don't even know what that means. Like, what would that look like if I was teaching the students? If you want to use any of the examples in here, have at her. You're welcome to use them. We've hyperlinked where we got them from. If you want to go in and get some more information from there, again, it's entirely up to you to use. You don't have to use any of this. This is not a mandated document. Over on the right-hand side, you have formative assessments. Remember that the only one that you assess is the learner outcome, and that's the summative piece. Down here, what you're seeing are formatives. These are the touch points to see whether they're actually getting what you wanted them to get. And as you move through, you see there's more examples, illustrative examples of how would I unpack that skill. Then I see the new skill says express positive and negative numbers in a context. Here's what it looks like as an achievement indicator. Here's what it looks like as illustrative examples. And again, you're welcome to use or not use. Here is a formative assessment that you can use. And if it has already been tagged with surface or deep, this one's deep. So remember, surface level is teach me the foundations, brand new words. What do they mean? Give me some examples, like get me into it first. But then when you want me to start connecting those pieces together, that's already deep thinking. And so this is a formative assessment for deep thinking. That's what we're looking for. There'll be more of these to be added in. So it just goes like that all the way through the document, unpacking each of your skills and still keeping in mind what your knowledge and understanding is, right? That's still in the background there. Then you have all of these illustrative examples, new sets of assessments. It goes like that all the way until we've done every skill that was listed in that cusp. And that will take us down to the bottom where you'll have a section of resources. So if you have or are using Mathology, which you all have access to through Learn Alberta, there's your connections to that as well. Here are your connections for Math Up, and nice that Betty's on because Betty is your Math Up connection person in to go to. That would fit with the cusp that you just taught. Here are your connections also to grade 7 books. So here are some additional pieces that, depending on which book is being used in your division, this tells you which pages you can find some of the material that you're teaching in. NCETM is, and I know I'm throwing lots of info at you, and but it's just something to sit down and explore when you have a few minutes. NCETM is the UK materials that were created for their teachers to support their new math curriculum. They have such similar outcomes in their curriculums, maybe not always in the same grade that we have them in, but we sought permission from them to use their resources. And they said, absolutely. So if we have a match to what you're teaching, you will see it here. Sometimes there's one, sometimes there's 7, 8, 9, 10. Sometimes there's none. If there's none, I will put a different version in there. So NCTM did the same thing as kind of core knowledge. What they did is they went through and they unpacked, I've never taught this before, so what are some strategies that you as the teacher can use to teach the unit? They provided them with some PowerPoints. They provided them with some activities that the teachers could use, some assessment ideas, listen for, look fors. So again, something to look at, not suggesting in any way that you would just click it on and just use everything, because not everything's going to fit to your style of teaching. So go through it and see what works for you and what you want to glean from that. The websites and resources to support learning are the ones that are most relative to the cusp that you just taught. Here are resources for inclusion. So if you're looking for some ideas for differentiation, you might want to look in here. These are specific to math. These are areas that have been already done by other school divisions. So these are resources that were developed, for example, by Edmonton Catholic. We have some from Learn Alberta in here. We have the ARPDC, and anybody else who wants to share into this. We have Alberta Teachers Association has some great sites. So if you haven't been there, you need to go and have a look at those as well. And then the new numeracy toolkit that we created for over the summer. So all of those pieces are available to you, and they are not specific just to this cusp. They fit to your cusp, but they're also generic and would show up in every document that you see. Karen Bloomhagen from Explore Learning has gone in and already curated which of the gizmos fit to the cusp that you just taught. So if you see a gizmo here, it's a match. If you don't see one there, then they didn't have a good match for it. Below that, you also have a section on Indigenous lessons. How can I connect Indigenous learning to what I'm about to teach or have taught? And then problem-solving tasks. These were curated by the Calgary Consortia from New Zealand NZ Enrich materials that they put out. And they have fantastic materials. So they kind of group them together to say these are the things that work for a grade 6. So again, you have a lot of information. You see a watermark in the background says in progress. They are not done. They are living documents, so they will change. Our goal right now is just to get them all posted for all of your organizing ideas so that you have them, and then we can start redoing them or just putting more ones more up already. We had to take them down. We had some of them up and we had to take them down, change the title on them, which already gave us a chance to go in and put edits in. So some of them have already been edited and added to. So here's your 1.2, same idea. I'm not going to go through it all. Just here's your new set of information. Here's your new skills, new sets of illustrative examples, new assessments, etc. So it gets longer. The more cusps you have, the bigger the document becomes. At the very end of your document, you will find a section on literature, and those will grow over time. We're looking for books that you could have in your classroom that could be fictional, but tie into what you're teaching in that organizing or in that learner outcome. And how it might fit. If you have books that you find are really good for this particular organizing idea and that numbered outcome that you were teaching, just send them to me and we'll gladly include them in here as well. We just haven't had a chance to add in the rest of these or put more in. Again, living documents we'll add in as we go. So this is what a CPAR document is. So there will be more coming. There's lots more to be posted. We just haven't had the time right now to get them all up right away. Are there any questions about that? I know that there's a lot of info in there and you just need time to go through them. You can go and check out grade 5. Some of you teach a 5-6 split, so go have a look in the grade 5 documents because they have a few more posted. Grade 4 have a few more posted. K to 3 already have all of their numbers posted. All of their patterns are posted. So you can share that with your colleagues if they're not aware of those documents already being up there. They're also being posted for science, K to 6. They're also being posted for ELAL. So those are up already. K to 3 in one group and 4 to 6 are already posted in another group. So, and I know as homeroom teachers, you often teach all of the subject areas so that you have them there. Okay, so let's keep going. 6N4 was one we said we kind of wanted to look at. Is some people were saying the kids don't know their math facts. They're just really struggling. Some of them can't regroup yet. They're just struggling with some of the basics. So I'm not going to go through and teach the standard algorithm, but I do want to just offer, in case you haven't seen, some other modes that we might be able to use for multiplication or division, especially if I don't know my math facts. Like, what do I do? So we'll have a quick look at that. And then we'll also talk about the introduction of unit fractions, and we'll do that through the use of money, again, on a number line. And that unit fraction is so important. We've always had unit fractions in our curriculum. That's not new. We maybe start them a little earlier now, and that's okay. But we've kind of always given, unit fractions about this much of information when it maybe should have been this much time. Like, they didn't get as much sort of in-depth work than we could have done. And it would have maybe made that work with fractions later on for students a little bit easier for them to maneuver. Okay, so let's keep going. So in the money context, and I'm not going to go through all of these slides in detail because you saw them in the last session, in session 2. We are using money, I am using money for sure, in the context of base 10. So I'm not using base 10 blocks at all. I've replaced them with money right now so that we're getting that financial literacy going in our heads. But money offers me the value of being able to show a student what I'm talking about. Ones look different than tens. So if I don't get that place value stuff, this is very real. And that's something I walk around with in my pocket. That makes sense. The base 10 blocks, excellent tools. I'm not saying do away with them because I wouldn't, but I don't walk around with those in my pocket. And some students right up into junior high are trading in base 10 blocks, but they say, why? Who cares if I take these 10 little ones and make a rod out of it? What do I care? Because there's no context for them. We could have solved that issue by saying, we care because I don't want to walk around 12 loonies in my pocket when it could be 2 small coins and a $10 bill. So we give them a context for that trading and converting. It's not earth-shattering, but it's real. And that makes a little bit more sense to them so that when I bring the base 10 blocks back out again, a lot of them say, oh yeah, that rod, that's a $10 bill. Okay, so you just equated them to something. It just makes it a little bit more real for the students. So we're using this. Notice that there's no decimal on there because we just talk in terms of dollars and cents. We're not worried right now about the decimal. Yes, by grade 6, they should know a decimal and they should understand what it means, but you might have kids that don't. So initially when we start, and maybe that's where you have to start, I don't care about the decimal. Eventually we want to get the decimal in there because it helps to separate the cents side, the side that's just building enough money to trade for $1. So everything on the left-hand side is dollars. Everything on the right-hand side is cents. And that starts it off for them. Instead of me just saying, every time you move from the decimal, you multiply by 10, all true, but that's just a process again, right? If I don't get that, why do I care about that? Or what does that really mean? Well, if I take a loonie and multiply by 10, I do get $10. If I take $10 and multiply by 10, I do get $100. This is real. This makes it meaningful to them. And same thing with the division. So that's the piece that I continue. I know people say, you're onto that money thing. I said, yeah, I am, because I see the value of it. And again, people are saying, I've been trying the money, and yeah, you're right. They catch that. They're actually more engrossed in the money because they like the money. So again, the left-hand side is the dollar side of our decimal sign. This side is our cent sign. You might be wondering why this is here if you missed the second session. This is another way to use your base 10 blocks. My pet peeve with base 10 blocks is when I wanted to teach decimals, I had to change the rules on them. I'd have to say, change of plan. The flat is now going to be a 1. The rod is a tenth, and the unit's going to be 100. All true, but I lost half the kids. They had no idea why I was doing that, and I hated it. But when I was working with my other colleagues from another country, they said, why do you guys do that? And I said, I'll bite. What do you guys do? They said, well, we don't do that because that would just confuse them. I said, okay. So then they said, we take the flat and turn it over. And I thought, oh, that's brilliant and so simple. And just have to be there every day. In fact, they abandon it really quickly because they get it. But what do I see? I see 10 rows. What are 10 rows? Well, each one of those is a dime. What are each of these holes? There's 100 of them. Each one of those is a penny. So now I have my tenths and my hundredths. I'm not going to talk about that right off the bat, but that's really, we just tell the kids, when you fill all these up, what you get? We get to trade it for $1. Excellent. Love that idea. So that's also another way that you might want to approach it if you haven't done that. In this is a slide deck, and I won't go through the whole one. I'll just show you the highlights of what's in here. If you haven't done money with the students, then you might want to start with something like that. This is a slide deck that we use basically starting with pretty much grade 2s, do it this way, and up. But this is one we developed for grade 4, just to make sure with the introduction of decimals that we were catching on to what needed to be done. But it definitely could be used in any grade, especially if I've got kids who can't add. They can't regroup. They can't figure out that I have to line up the decimals. Why? Well, that's easy because cents go with cents and dollars go with dollars. In money terms, that's a no-brainer. But if I've never seen any connection to that, those would be the kids who are saying, why do I have to line up that decimal? Why can't I just put them to the left and just line them all up? That's because they don't have a context of what that's going to. So we use this strip on student desks and we say to them, everything on this side is dollars. Everything on this side is cents. If it's grade 2s, I'm only going to be working here. They see this, but we don't do it. Over here, I just start with this. Okay, we're just going to do regrouping, and they do 2-digit addition plus 2-digit or subtraction to 100. If I'm doing this with older grades, I will start with dollars. I will also start with cents. You could do 100 cents if you want. And every time you get over 100, you start getting into the dollar side of it. But I will eventually start just calling them out. And part of your curriculum is also, can students hear the number, the spoken word, and could they write the number down? In this case, I'm saying, show me the number. So the first thing I ask them to do is show me what the values of those boxes are. Can they match them? If they've never done money before, that's a starting point. If they've done money before, that's a non-issue. I don't need to go there. So I will say, show me $23. So they will show me $23. This is a base 10 system. There's no 5s, there's no 50s. If I say below that, show me $16. They would never see this. I'm putting this on here for you so that when you go back over it later, you kind of know, but I would never show this to them on the board. I will call this out. And so they'll show me $16 below. Why? Because I want them to put it together. I want them to find the sum. So when I find the sum, the coins go together. They look like they should go together. Those are the ones. The 10s are $10 bills. They are purple. They should go together. So again, it's the visual of adding, subtracting, and I can do that into hundreds, into thousands. I can go up to 10,000 easily. If they're mastered addition and subtraction in 10,000s with dollars and cents, they're away. Whether you add 100,000 or a million, what's the difference? It's not going to be different for them. They get that part. But they'd have to have some basic knowledge of doing this. So this entire slide deck is created that way, right? And I don't show them the numbers. They just go through it. I might do something like this when I get into the hundreds, and there will be numbers with regrouping in them. And initially, when you do a question and they've never had practice at this before, they won't regroup them. What they'll do is they'll add those 4 loonies to the 7 loonies, and they'll have 11 loonies all pulled together down here. They will give you the right answer. And I say, great job. You got the right answer. But there's one problem. I really don't want to walk around with extra weight in my pocket. And you know, that many loonies is a lot of weight. Is there anything that you could do to make that a little bit lighter for me? Oh yeah, we could take 10 of them and trade them for a $10 bill. Perfect. So from now on, I'm not going to tell you that. I don't want to walk with extra stuff in my pocket. That's your job to make sure that you have done that work. So if you don't do that and give me the right answer, I'm going to tell you that you have got the right answer, but you're not quite done. And that's going to tell you that there could have been some regrouping somewhere. And that goes for bills and coins alike. So that's just how we navigate through addition, subtraction, doing that kind of work with the students, asking them, what would be a reasonable estimate for your answer? When you put those numbers, what do you think approximately it should be? And again, if they can't estimate, Then if they don't have a lot of loonies, but I have a lot of tens, I could just count the tens up. That's a reasonable estimate of my sum. That is a way we can show them how that would look. So that when I just do the symbolic paper and pencil, then I have a way of looking at it and saying, oh yeah, those are my tens. I could just add those together and that'd be an estimate. Okay, so you're getting the idea of what we're talking about. This goes on, it can go into the thousands, it can go into whatever number you want, and whether or not it makes sense to them. So we do differences, and then we go into things like dollars and cents. Notice I don't have a decimal there. I'm just saying dollars and cents. Show me this many dollars, and is the decimal, cents, show them to me. Same rules, regroup, 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 wherever you have to find me the answer. We typically do this on the floor with the students because then they can work with a partner and spread that money out, and they can just show us and we can walk around quickly and see what they've got going. So that slide deck, there's more to it. I'm not going to go through the whole thing, is available to you through this slide deck here. You'll have access to it. All right, so how do we meet some of the outcomes? This is one I won't go to right now because this came from your second session. But again, I'm just pointing it out to you that we talked about regrouping there. So this is the place that it kind of links to it. This gets to the place value conversation. So again, if your students know the place values of the digits, let's check if they understand the difference between position and value. So if I say to them, what number do I see here? Well, they can count it if they don't know it, but 36. What digit is in the tens position when I write 36? 3. How many tens? Well, I can see them. There's 3 of them. How many ones in the number? And if they say 6, I want to ask them to think about what you just said. How many ones in the number? Not what number is in the ones position. Different question. So I always say, I'm going to reframe the question. What if the bank said they ran out of anything except loonies? How many loonies will you have to give me this amount of money? Oh, 36. Right, you got it. So these examples just go on and do those same types of things. So knowing the difference between position and value. And the bigger the number, the more questions I can ask. So for example, how many hundreds in the question? Great. How many tens in this? Not 2. There are 12 tens in this number. So again, it's getting through and understanding those differences. If they need the columns, and some teachers said, where are the columns? And I said, I didn't put the columns in because columns don't usually show up with money. And to be honest with you, I hear too many times I even hear it when I do parent nights. Oh, we're going to do place value. That's columns. And I said, is the column the place value? Yeah. Well, no, the column actually is just separating the digits out into their place values, but they think that's what place value is. So to avoid that with money, we don't really need it. We just don't put it there. But if you want it, then put them in. I mean, not saying that they shouldn't have it if it helps them, but I would just put the dollar value at the top and just go from there. Don't change anything else. Still ask them what's the number, how many hundreds, how many tens, how many ones, whatever you want. The bigger the number, the more you can ask. Okay, so that's an important piece of understanding place value and understanding addition, understanding multiplication. When we start talking about when I'm multiplying numbers, same idea. So again, when we start getting into some of the standard algorithms or reliable procedures for multiplication and division, notice what it said, are reliable procedures. It didn't say it's the only thing that you have to use. So yes, I want them to know how to do the standard algorithm. But if they have been beating their head against the wall 3, 4, 5 times, they don't get it, then I need to find another strategy for them. We'll unpack those in just a minute. So again, some of these start small. You know, when it comes to decimals, kids get stuck and they think this is really hard. But if they've been doing money, they'll see this as $14.42. Much different than if they just got 14.42. So $14.42 divided by 7 people. I know it's an easy number, but just so that they get a sense of how that might go. Well, they'll say, I'll take the $14 first and divide it into 7 equal piles. Okay, well, how much is ever going to get? $2. Okay. What about the 42 cents? Well, I'll do the same thing. And how much will they get? 6 cents each. Okay, great. So they're starting to get the sense how they're dividing those up and how they look different. So again, what strategies do we offer students for multiplication or division if I don't get the standard algorithm, right? So I won't go through the standard algorithm because I'm going to assume that we're there. In grade 6, you probably have already checked. If you're not doing the multiplication division yet, you're going to want to check, starting really simple. Can they do a double digit by a single digit in the multiplication? Can they do 2-digit by 2-digit? Can they do a 3-digit by 1-digit? Can they do a 3-digit by 2-digit? Where are they at? What's your stopping point and starting point to say this is where we need to begin? And again, we're well aware that students are going to be all over the map and that you may have some that are right there at 38 times 8, and you've got others that are 324 times 250 would have been no problem for them. So we know we have that big gap, but we do have to start at least where they're at, and that's a big piece. I can use base 10 blocks. That's a beautiful visual for double digit multiplication, 2-digit by 2-digit. And it really gets to that whole surface area. How much area did I cover when I did this, when I multiplied those two numbers together? So if you're not familiar with that, it works basically that I have my number, let's say 22 by 31. So they put the 22 at the top. So I just make a big L or an open side, however you want to do it. I turn mine the other way and make an L. That's basically what I do. And so up top here, I'm going to put the 22. So I'm going to create a 22 with 2 10s and 2 1s. And down the side, I'm going to do my 3 10s and my 1 1. Does it matter? Could I put the 22 here and the 31 there? Absolutely. No, it makes no difference. They can pick whatever side they want to start on. So a 10 times a 10 or a rod times a rod fits very well into a square that we called a flat. And what do I know about a flat? 10 times 10, it's got 100 on it. It's a perfect match, perfect fit. So each time I'm multiplying the rod by the rod, I'm going to get a flat. So I fill those all in. What do I know about a unit and a rod? A unit is exactly the end fit to a rod. They are a perfect match because 10 of these fit right into that. So what I need is something that fits the width of the unit, but matches the length of my flat. And the only thing that does that is my rod. So each unit's going to get a rod that sits beside each one of these flats. Same thing down here. So when I want to count my answer, what is 31 times 22? It's 100, 200, 300, 400, 500, 600, 10, 20, 30, 40, 50, 60, 70, 80, 2. If you ever have parent nights, do that with your parents. And what you will hear is, oh my goodness, why didn't somebody show me that when I went to school? That makes total sense to me. And this is not just for multiplication. I could give you one of the factors, right? We're going to bring that word back in again. I could give you the product, in other words, the answer, and I'll use the factor. I'll put it on one of the sides. I'll build the answer. I know it has to be a rectangle. This is a rectangle shape or a square shape. Can't have any holes in it. And then I can figure out what the missing side is. So I can do division with this too. The only downfall of this is it works best for 2-digit by 2-digit. It could do a 2-digit by 1, but then you just have all these rods and single numbers in there, which gets a little bit problematic as to how many you have available. So what are some other possibilities? I could use a box method. And the box method offers me some opportunities to break up numbers. And for some of our students, that makes total sense. Don't show me the algorithm because that's not working for me. But if I take this number and divide it up, and I take that number and divide it up, I could go 400 times 10 is 4,000. 30 times 10, I know I just add a zero, is 300. 9 times 10 is 90, and so on. And then they add up their like terms and they go from there. That makes total sense for a number of students, and they prefer that. And there's nothing wrong with that. So I can turn it the other way. It wouldn't make any difference. However, there are some students who are going to say, I don't know 400. Like, I don't know what to do with that. Like, that's too big a number for me. So again, you have in the background here another slide deck, which you can use if you so choose. But we're going to leverage the grade 4 number statement. And it said, investigate patterns in multiplication and division of natural numbers by 10, 100, and 1,000. So I'm the kid in your class who has no idea about anything beyond maybe a 1, 2 times, 10 times. Okay, got that piece. Ones, tens, hundreds, thousands are easy for kids to learn because the pattern of the zeros is an easy structure for them to remember. And if I know that, I can do any question you give me. I will get a correct answer every time, even though I don't know my 6 times 9 and my 7 times 8 and whatever else you want. So if I look for a pattern, one $10 bill, in other words, 1 times 10 is 10. 2 times 10 is 20. 3 times 10 is 30. So I can say the kids are saying, oh yeah, well, we know what that's going to be. So what's the pattern you're seeing? Well, the base number, or the natural number, times 10 means I take it and add a 0. And that's normally what we tell them. Let's let them see it. How can they prove it? They could count them. That's an easy way. So when we go to the next slide, we basically ask them then, based on those patternings, what do we know about 8 times 10? What would we predict would be 9 times 10? What would we think 10 times 10 would be? And so on. So how could you check any of these? Count them out. That would be the fastest way to prove to me that, yes, I got it. So I'm going to extend that now to hundreds. When I have 100, I get 100. When I have 200s, I get 200, and so on. So this gives me the pattern of what do I know about hundreds? When I multiply by 100, I add 2 zeros. When I multiply by 1,000, I add 3 zeros. In grade 4, when I do that with them, I say, okay, put your thinking caps on. If I put 10,000 on the board, what would you say would be the pattern, even though they're not going there? Oh, you'd add 4 zeros. What if I put 100,000 on there? We'd add 5 zeros. Okay, you're getting the idea of how this works. They don't go there in grade 4, obviously. So I would just do some quick oral checks with them. I wouldn't have them write it down. If you feel writing it would be better, that's great. But they've got an idea of how that looks. And so when we talk about multiplying and dividing in grade 4, they need to be able to multiply a 3-digit by a 1-digit, divide a 3-digit by 1-digit. So if that's their goal at the end of grade 4, that's your starting point at the beginning of grade 5. What they're going to end with in grade 5 is your starting point. But I'm going to argue with you that this might be your starting point for some of your kids in grade 6. That might be where you have to start with them first, because they might not have the tools. So if I'm going to multiply, what can I do? I could use the box method. I could use an expanded version of that box method, just doing it sort of paper and pencil. I might break up the 253 into 250 plus 3, and all of this is going to get multiplied by 7. I could say I don't like 200. I'm going to make it 2 times 100. And then I could go 2 times 7. I usually say to students, I bet you know your 2s. What's 2 times 7? They go, I don't know. What's 7 plus 7? 14. Okay, so you do know your 2 times 7, right? They just context for them. So we put this in, and then they can add them up on the side. There's no regrouping. Not when we do it this way. It's pretty simple. So then they can go through and figure out what their answers are. But for some of them, this is very confusing. So we'll go back to the box method. 253 times 7. Short form of this, some might say too big, got to break it up. Some will say still too big, got to break it up. And this is where there's a group of students that I work with that struggle. They're grade 5, 6 students who are not at grade level. This is where they're going to go. And not because I told them to go there. They go there because they don't like these numbers to be big numbers. They like the pattern of 1s, 10s, 100s, thousands. Anything you throw at me with that pattern, that works. And they might not even like the 7. They just might say, I don't want to do 100 times 7, because what's 7 plus 700 plus 700? Okay, that's difficult for them, especially if they don't know how to regroup. So what they do is they break it out, and they take every value and break it down, the 50s into 5 10s. Even the 3s in some cases become 1s. Over here, you see the 7s are 1s. Not every child will do that, but there are a lot that do. And you might say, oh my goodness, it's going to take them the whole class just to do one question. The answer is, first time takes them about 15 minutes, 10 minutes to do one question. After that, they get the idea. This happens really quickly. I'm not looking for perfection in a box. All I need them to do is put their numbers out, however they're going to arrange them, and just draw random numbers down. We just use scrap paper to do this. But what they like is that they can simply figure out 100 times 1 is 100, 100, 100, 100, 100. Eventually, some of the kids pull those together and make them 2s, and like they do that by themselves. So they just count 100s, just like we did the base 10 blocks when we counted them. And that's easier for them. And this will give me the right answer. If I want to leverage that thinking, that I'm the kid who only can do the ones, tens, hundreds, thousands, whatever you're going to give me, what numbers I'm going to work with. If that's all I can do, then I can still do every division question that you can throw at me. There's nothing you can give me that I can't do, even if it's a 2-digit that I'm dividing by. So here I've got 868 divided by 7. 7 is the number that we're going to work with. 1 times 7, 7. 10 times 7, 70. 100 times 7, 700. 1,000 times 7, oops, too big. Way over what I have, so I'm not even going to worry about that one. So now I'm going to go in and say, which one could I use? What's the biggest one I could use in here without going over? I'm going to use the 700 one. So put the 100 beside it. Instead of up here, they just keep a running total down here. Put my 100 in, subtract. Now I can go by tens if I want. Some kids will double it, but not everybody will. So subtract 70, no regrouping. Here we go. Put another 70 in, got 28. Now some of them might say, I know what 4 times 7 is. Okay, great. Some of them will go 1, 1, 1, 1. Whatever works for them. I mean, we're not directing this. It's the process that I want them to understand of how to divide this number down so that they can figure out what the quotient is. All they do is add up this side here, and that gives them their total. That's their quotient. It's not earth-shattering, and you might say, I don't want to show that to the kids because it's going to take them too long. They do this really quickly. They will get very good at this, and they also get really good at just taking out whatever they don't need over here. So give it a shot if you have some students who are struggling. And this could be 25. This could be 1936 divided by 25, and it'll be 1 times 25, 10 times 25, 100 times 25. Same thing. Stop when the number exceeds what I'm dividing by, because that's what I'm going to work with. And some of the students, when we have a number like this, you'll see I nudge them. I'll say, hey, do you know what 2 times 5 is? Yep. Okay, well, why don't you write that one in there too? Because then maybe instead of doing ones, they'll grab the 10. And some of them will say, hey, I even know what 3 times or 4 times 5 is. I'm going to put it in. Great. Perfect. They start to tool that up because they themselves get tired of the ones at the end. So just a strategy, a possibility that they can use. Okay. So there's some samples in there in that slide deck that you're welcome to use. All right, so as we go through, there's also some samples in here about multiplying a decimal number. So if your students are struggling with visualizing that, if they see this, most of them will say that's 34 cents. I need 4 groups of 34 cents. But here's just a quick little video that you might want to use if you want to use grid paper to do it with the students. Okay. And here's another way that you can do it. Grab grid paper. You can print this off free off of the internet. And if I use 100 square, this is 1. Each one of those rows would be a 0.1 or a dime, same as what we're using sort of with the money. So here is $4.50 times 3. So that gives them another question. So $4 is right here, and each one of these is a dime or decimal 1. So there's my $4.50 times 3. Build my box, count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One of this with one of these makes another box. There's 13.5. Some of our students need that kind of work for decimals. It makes more sense to them. And even if there's a decimal up here, that's fine. That doesn't make any difference, right? So again, just other strategies that you might want to use with the students. You're replacing right now money for base 10 blocks to go back to them, but you're not, I just start without them. So here are some resources that you can use again that would help you with what we just uncovered. And equally as well, there are some resources from Ontario that would be, in some cases, they're not games, but they definitely are quite interactive for the students. And so you might find those helpful to use as well. Okay. We've done all our work with quadrants already, but you might want to revisit them. The last piece that's in here, and I won't spend a ton of time on this, but this is the translations or transformations, sorry, that you have. You're going to be doing them a little bit more in depth. And this time we're going to do maybe 2 moves in one, so multiple steps or multiple moves. But what I want to just point out, you can look through the examples that are in here, but I want to point out at the bottom here is alternate ways that we can do a translation. And you are not required to teach that to students. The only reason I'm putting it in here is, first of all, it does show up in some of the textbooks, and some of the teachers are saying, I have never seen that before. Like, how do I read this? So I'm just going to go through that part of it quickly, but there are some websites I'm sharing with you that they use some of that. So you might want to share it to the students. It's not difficult, but you need to know what it means. So here, instead of doing the ordered pair and saying, I'm going to slide it 2 units this way and this, and just using that language, you might write R2, U3, which means right 2, up 3. So that's one way that I can do a move. And that would be a typical grade 5 kind of wording that we would use when they first start with coordinate grids. This one is saying take each of your X coordinates. So what if you ask them to draw a hexagon on the coordinate grid and you ask them to label the vertices of that hexagon? Then you're going to have ordered pairs there. And now you want them to take that hexagon and slide it 2 units to the right and 3 units up. What you're really going to do is say every coordinate that they have, the X value will have 2 added to it, and the Y will have 3 added to it. And that will shift the whole set of ordered pairs to the right location. And now they could label it that way. So that's just how you read this. I am not suggesting that's part of their curriculum. This is the same thing. When they write it like this, there's lots of ways this gets read. But right now, when we talk about transformations, this is X over Y. So X moves 2, positive move 3. So I'm moving 2 to the right, 3 up. I have to know that this is X and Y. And that's important because I've got some links in here for you that you can use with the students if you want to use these. They're interactive. They can even check their work as they go along, but they will use one of those notations. So just that you're familiar with it. The nice thing about this is this will take you to the website, is every time the students click it on, they get a new question. It's not the same one over and over and over again. They get new questions. So you can have 2 kids sitting side by side and they can each be doing different questions. And this is where you see some of these slides that come into play. So these are just resources for you to use when you get there. Obviously, tissue paper is still one of those standbys every time that we can use. You want me to take this shape and you want me to flip it over. I can flip the tissue paper over, lay it down, and then I can start to mark it out, because spatial is really hard for some of our students to see. Lots of adults have difficulty with spatial, visual pieces. So just having that tissue paper sometimes is a real easy piece for them to do. There's some additional activities, but I put a note in there. There's just tons of ads that just kind of bugs me. Here are some places you can go into the existing books that you have in your school if you're looking for some additional ideas. And part of yours in grade 6 was here, visualize and describe combinations of transformations. Like maybe they did a reflection and they did a slide. So is it seen anywhere in here? And all of these are multiple steps that they could, depending on where you start, how you get from one to the next one. So again, these are just some samples just to give you some pictures that you can share or use with the students. But this is a link that you can go to. Math Links 8 has an entire unit on tessellations. We didn't do tessellations in this last curriculum. I know lots of people taught it, but it's actually not in our curriculum. But the whole unit is there, and they had some really great pictures. So if you just need some images that you want to use, perfect. Okay. And then the last piece is on fractions, and we covered fractions once before. So we talk about fractions. I'm not going to go through the research part of it, but what I will show you is that we can use your money again on a number line. Okay, we did all of these before, so I won't use them right now. Oh, come on. There we go. I could put my dimes on a number line. I could take a number line and change it to cents to give them context and create unit fractions that way. So this is my first out of 10 dimes or over 10 dimes, possible 10 dimes. Here's my second out of 10 possible dimes, my third. But what I'm wanting them to see is that this is how far the distance is for the first out of 10 dimes. So some of the kids call that my 1/10 jump. This is my first 1/10 jump. This is my second 1/10 jump. This is my third 1/10 jump. But what that's doing is saying to them, unit fractions can be counted on a number line just like whole numbers were. And a lot of kids don't even know that. They don't know that unit fractions are anything beyond shading in one of something on a wheel, and then I count the somethings that are there, and I write for you, this is 1 out of 8, or 1 out of 10, or 1 out of 15. Unit fractions are a whole lot more than that. And in grade 5, they use the unit fraction to pull apart a number like, what is 5/11 written as a product? If I don't understand unit fractions, for me to end up with saying 5 times 1/11, that's a big stretch. So I need to make them, I need them to see it. So this started in grade 3, but right now in the current grade 6 program, they didn't have all that background knowledge. So you will have to do a little bit of work on unit fractions because they will not have that background and they won't understand it. I have these grayed out because I don't even use that language to start with. I just talk in terms of dimes out of a dollar. So you might want to use a number line that's uses something like this, change these all to cents. You could put dimes in the middle, you could put pennies on top, quarters on the bottom, and that's what you will see in the slides that are in here. The students went through, they put nickels on, they put dimes on, they put pennies on, and they put quarters on. So this is, I know it's hard to see, but these are all of them put together. And we just asked them to compare. What do you see at 50 cents? What do we notice about the fractions? We can talk about equivalent fractions because I see the same 50 cents, but I don't see the same fraction every time. But are they equivalent fractions? Yes, they all represent the same amount. So it's just doing some of that physical and visual pieces with them before we launch into the paper and pencil and just say, you want to find an equivalent fraction, multiply the top number, the bottom number by the same thing, and you'll have an equivalent fraction. Procedurally, absolutely correct. Conceptually, that's just a process. That's not getting to the understanding. So we want to just take the time. There's a template in here where you can ask the students, you could do the first one with them. So if this is 0, this is 1, then this becomes 1/2, this becomes 2/2. You as students fill in the rest of them. And I've got some samples in here. And this is what some students wrote. This is a sample of student work. Some of them said, this is my first 1/5 hop. This is my second 1/5 hop. This is my third 1/5 hop, my fourth 1/5, and so, excuse me, and so on. Some students just wrote it as 2/5, 3/5, 4/5. Okay, whatever works for them is either way is fine. If I move the 1, that will get me into improper fractions, and that's good. That gives me that opportunity to have that conversation about what's going to happen. And in particular, if I use the bottom row, which are quarters, I can have some pretty rich conversations about what is this? Well, that's 4 quarters or $1. Perfect. What's this? 5 quarters? Well, that'll be $1 and then 25. So now I have a 1.25 here. That's perfect because now I have decimal conversations. I also have 1 1/4 mixed fraction. So just leveraging money to have that conversation about how do we flip to a decimal? How do we flip to a mixed fraction? And then just do the symbolics. Once they've got it, it's just making it available to them first. So here are some sources for the research in the fractions, if that's helpful to you. You will find where some of these are always posted on the ARPDC, so we'll get those up as quickly as possible. So go to grade 6, look for session number 3 in the planning, and that's where you're going to find this. But I will put the slide deck into the chat box for you right now so that you can grab it and not wait for it to get posted here right away. At least you'll have the slide deck and you can go in and have a look if there's anything there in the additional slides that you're looking for, then you can have access to that. Okay, so that's there for you. You can grab that. And that pretty much covers everything that we're going to do for now. There's a lot in there and there's a lot of info. So we know that when they come back in January, there's some repetition that needs to happen to get them back in, but that doesn't mean that we won't have that time. So if you have any questions, don't hesitate to email. I'm going to just stop the video. So if anybody has any questions, you're not recorded.